When software designers are working on new software or implementing or building code, they often use programming concepts. These are the basic structure of code that tell our computers, devices, or whatever we're using what to do and how to do it, such as storing data, making decisions, repeating actions, and organizing instructions or code. If programming languages are like languages, then our programming concepts are like the nouns and verbs of our programs. They essentially provide structure and function to significantly improve the way our programs work. Let's cover the different programming concepts that we're going to be going through in this video. First, we're going to talk about variables. Then we're going to talk about functions and loops. From there, we're going to talk about conditions or conditional statements. We'll be talking about operators, pseudocode, and finally, we'll be ending off with objects. Here, let's talk about variables in programming first. So a variable is somewhat like a storage container. This is where code is used to store data that continues to change. It could store things like user input, scores, or even calculation results. An example of a variable would be something like a video game. The starting value is 100, then as we progress and as elements change, the variable does as well. So for example, we have an event, we earn 50 points. Now our score is 150. From there, we might have a boss fight or a boss event, which adds another 100 score. So our final score is 250. That variable of score, we set that so that can start to change. And so we can record that and store data in it. So our variables essentially store our data that is going to change as our programs start to implement different code, start to run, start to encounter different types of instances or events. And that's what our variables are for. Next up is our functions. Our functions are like a block of code that perform a specific task. It can be reused among other tasks, for example, calculations, password checks, and it makes our code organized, easy to read, and easy to update. So here's our example. What we have here is the function. That is this greet here in this box. Below that, we have the print hello world. So instead of needing to always type print hello world, we can define greet as a function. And then from now on, whenever we use greet, it's going to print hello world. This is useful, especially if you have multiple different types of functions where you're going to be reusing them throughout a program. So we can set we can define our function first, and then we can just reuse it as much as we need to. So we can have greet, and then we can implement greet all throughout our actual program in multiple areas and multiple code, and that greet will symbolize the print function. From here, we have variables and function flow. An example of a variable here is user underscore name, and it has the value of Alice. So Alice's username is Alice. Then we have a function. For example, generate underscore greeting, parentheses name. This might return hello plus name. Now let's go into variables and function flow. Essentially, our variables store something, our functions use whatever our variables store, and then we can use that to get an output. So our variable in this case is user underscore name with the value of Alice. So the variable is user underscore name, and it stands for Alice. The function is to generate a greeting with user name. So for example, return hello, comma, name. So the output in this case, using the function and this variable, would be hello, comma, Alice. All you really need to know for the Tech Plus is variables store something, functions use it, and then we can get an output from that. In programming, we can use what's known as loops in order to reduce manual work and ensure that we met a specific condition for whatever our software is trying to accomplish. For example, let's say that we were working on an application and that application had a login system. This is what a loop might look like. In this case, the user might visit our website or the application, and they might start the login process here. From here, they would enter their username and their password. From there, we would check, or the code would check rather, that the password is correct. Now there's two ways that this can go. If the password is correct for that username, so the combination is correct, username and password, then the login would be successful and the loop would end. That's the simple way of doing things. Now, if the password was incorrect with the username, so the username password combination were incorrect, then we would go to no because password would not be correct. From there, we would see if we have attempts remaining. So the code would check, okay, how many attempts are left? Normally, for most applications, they give you 3 login attempts. So let's just use that as an example. If this was, say, the first login attempt, we would have 2 more. So the condition would be attempts remaining. Yes, since we have 2 more attempts left, we've only done 1. We could go back and the program would route us to enter our username and password again. And it might have a display message saying that was incorrect. Please enter the right password, so on and so forth. Now, if we go back through and same thing, the password is not correct again, the username password combination, we would go to no again. In this case, because we're on our second attempt, we have 1 more attempt left. Then the program or the code would route us back again to re-enter the proper username and password. If we entered the wrong password again, so all three of our login attempts failed, then we would go to no, meaning we have no attempts remaining, and that would lock our account. From there, the loop would end. So you can see loops are very, very useful for things that would require more manual work. Because, for example, if we had someone enter the wrong password once and the wrong username and password, and we didn't have a loop, that would mean that all they really need to do is just keep trying. There's no attempts, there's no block, there's nothing like that. Or in the worst case, if there wasn't a loop, it could possibly even log you in with the wrong password. But what our loops do is they ensure that we're going down a specific path. Yes or no, true or false. It's just creating scenarios where we're just ensuring that things are flowing logically and that whatever the user is trying to do is actually being done properly in order for that loop to end. So loops can carry on as long as we need to. This is just one example, and these are just two simple looks at a loop. These can get very, very complex in programming, but just understand for now, it essentially repeats code until we've hit a specific condition. In this case, the conditions would be either the login being successful or the account being locked because we had 3 login attempts and they were all unsuccessful, and then the loop would end. We just explored loops, so let's explore conditions. And conditions are essentially any sort of logic that helps us choose different paths, usually based on true or false conditions. So just as we explored with loops, conditions are just statements, and they allow us to build out our programming logic. For example, with a conditional statement, normally there will be a condition that has to be met, and then we branch off to false or true, or in the case of loops, we can go back up to another part of the actual statement and loop everything around again. But in this case, we have one condition and it's either true or false, and then it goes to some sort of action. So for example, the condition could be something like, let's just say someone is trying to access a file. And then the condition could be checking for permission. Permission is assigned, true or false. So if it's true, they're able to access the file. If the condition is not met, meaning they don't have the permission in this example, it's false and they're not able to open the actual file. So that's a really, really simple way to look at conditions and conditional statements. Again, we just explored this, so we don't really need to go too far in depth on this one, but just keep in mind conditions or conditional statements help us, and they're essentially just allowing us to have different paths for software in the event we have to have a true or false statement to lead us to 2 different paths. In programming, software development, and scripting, we use what's known as operators. These are different types of symbols like the ones that you see here on the screen, and they just help us perform math and logic operations. You don't need to know what each of these operators actually do, just understand they help us compare, contrast, as well as perform math and different types of operations between different variables. Next up, we have pseudocode. Pseudocode is very simple. It's just plain English steps that anyone can do that describe how a program works. They're commonly used for us to plan logic and to explain ideas before we actually code. Very, very commonly in programming, we use what's known as if statements, else statements, and statements, and all of these they're essentially conditions. If something, then this, else this. That's kind of what we were looking at with the whole conditional side of things. But in pseudocode, you can see here, we're not even programming anything. We're literally typing out English sentences in the English language or whatever language we're using. And then we can take that pseudocode and we can actually translate that into real software or programming code. These are useful because they really, really help people who are not software development oriented or they don't have any programming experience understand what's going on. So in this case, if an employee answers 8 or more questions on a quiz correctly, let's say it has 10 questions, it automatically displays a message saying, congratulations on passing the quiz, and it sends them to certificate download page. That's super simple to understand. Anyone can understand that. But on the programming side of things, that might be a bit more complex. The other part of this pseudocode, this is a part of the same thing, is else display message, let's try again. And then it returns them to the beginning of the quiz. So essentially, if they didn't get 8 or more questions right, it just sends them to the beginning of the whole quiz and they do it over again. This is a really, really simple example, but just keep in mind, we can use pseudocode to actually build out logical steps before we start coding and before we start programming and getting everything in the actual language that we're going to be using, the programming language. So we use plain English or plain language here, and then any software developer can just translate that into real code. An object represents one thing by keeping all the information and behavior of that thing together in one object. An object is often used to model things like users, carts, or game characters. For example, in this case, we have this little ogre guy, and he is an enemy character, but he has multiple different properties. He has health points of 100, color is green, his speed stat is 5, his methods of navigation are walking, attacking, and taking damage, his results are enemy 1, so on and so forth. So he's got a lot of different variables to him, right? He's got a lot of different information about him. If you think about it, Really, once you start to break these things down, it becomes pretty complex. But objects are very, very simple because they take a bunch of different information and they put it together in one thing. So, this little ogre guy, he's an enemy character, but he's relatively easy to conjure into one object, even though he has multiple different variables and pieces of information about him. And that also helps with using things later down the line because you can classify this as an object and then bring it up later and reference just the object instead of having to reference its properties, its methods, its results, its enemy name, and everything like that. And those are all of the programming concepts that you need to know for the Tech Plus exam. And those are all of the programming concepts that you need to know for the Tech Plus exam. In the next video, we're going to start exploring how we can organize code and overall code flow.